Question number 6. As I told you, 6th onwards we use integration to solve the differential equations. Now you have 3 techniques, remember. Variable, separable, homogeneous and linear. When you are given a differential equation, you should see which method should be used for the given question. So here, by just observing the given equation, 2 things are clear: that it is not homogeneous, as well as by linear differential equation even it cannot be solved. Why it is not homogeneous? Because degree should be same for each variable. Here 2, here constant means 0, so not homogeneous. Why it is not linear? Because when you have dy by dx, then you cannot have y square, तो linear भी नहीं है. So we solve by variable separable form. We separate the variables. With dy we collect all the terms having variable y. So I'll take this down, plus I'll take this one over there. So 1 upon root 1 minus x square as it is, I'll take dx over here equals to 0. Now very easily you can see that this is in which form? VS form, variable separable form. It is in VH form. Now we just integrate it. So integrating. So here you have integral of 1 minus y squared. It's very standard formula, you know. Integral of root of 1 minus x squared equals to integral of 0 on the right hand side. Right? So can you just recall what's integral of this one? If you remember, it is sine inverse y. What is this? You know, sine inverse x. And integral of 0 is any constant c. Required solution of the given differential equation. What is c there? C is arbitrary constant of the integration, which is arbitrary constant. Okay. Now, next question. There also you can do by variable separable form. You can see clearly. If I just write directly, you can see that you can rewrite like this: y squared plus y plus 1 into dy. I have dropped one step, remember. And you take dx in the numerator. So x squared plus x plus 1 as it is into dx equals to 0. What I did with dy, there is a term involving y. With the dx, there is a term involving x. Now it is a question of integration, remember. Forget about differential equation time being. So we integrate this. So integral of this, integral of this. Do you remember it is which standard form? It's a quadratic expression, and every quadratic, you know, it can be expressed as a sum or the difference of the perfect square. लास्ट टर्म क्या होना चाहिए? इसका कोएफिशिएंट डू इट हाफ 1/2 एंड देन स्क्वायर इट. सो y स्क्वायर प्लस y प्लस 1/4 होना चाहिए. 1 में से 1/4 ले लिया तो यू आर लेफ्ट विथ 3/4. नाउ ये परफेक्ट स्क्वायर हो जाएगा. सेम थिंग शुड बी डन हियर, रिमेंबर. x स्क्वायर प्लस x प्लस 1/4, y 1/4. आई रिपीट, कोएफिशिएंट ऑफ x कितना है? 1. इसका हाफ एंड देन स्क्वायर इट plus 3/4. You have done such questions number of times in integration, remember. Okay, now it is x square plus a square form. Okay, it is x square plus a square form. So if I do one more step for you, or x step if I show you. So here this is y plus 1/2 whole square plus this is root 3/2 whole square into dy, and same thing is for this, equals to integral of 0. Now what is the integral of this? You know, it is 1 upon a, that is root 3/2 into tan inverse y plus 1/2 upon root 3/2. Same thing here for variable x. 1 upon root 3/2 tan inverse x by, so here x plus 1 by 2 upon root 3 by 2 equals to integral of 0, which is any constant c. Now this 2 expression you can take over there, constant. So tan inverse, this is 2y plus 1 upon root 3. 2 will get cancelled, plus tan inverse, this is 2x plus 1 upon root 3 equals to, this is I suppose root 3 by 2 into c. This is a constant. This will take on the other side. If you want, you can leave it in this form, but you are asked to prove something, remember. So we need to get that form. Now we'll use which property? Tan inverse x plus tan inverse y. So tan inverse, this is 2y plus 1 by root 3, 2x plus 1 by root 3 upon 1 minus this 2y plus 1 by root 3 into here 2x plus 1 by root 3 equals to, you have root 3 by 2 into c. C is a constant. Take tan inverse on the other side. And here what you can do is, if you take here, I'll take tan inverse on the other side. So this is tan of root 3 by 2 c. Remember, this is a constant anyway. What I did, taking tan inverse on the right hand side. So from numerator, I suppose you can find root 3 common. So what will get? 2y plus 1 plus 2x plus 1. What about denominator expression? Root 3, 3. That will multiply with this. And then I'll take 1 by 3 outside. So you will get the 3 minus, I'm opening these two brackets. So this is, I suppose, 4xy plus 2y plus 2x plus 1. Just I have opened the bracket, remember. Fine. This is simple algebra, remember. Now here you are left with how much? Root 3, 1 root 3 will get cancelled. Right. So here I suppose you are just left with root 3 here. And what is this? 2y plus 2x plus 2. What is denominator expression? 3 minus 1, that is 2. Here 4xy minus 2y minus 2x equals to tan of root 3 by 2c. That's a constant, remember. Root 3 you can take on the other side. So here you have 1 by root 3 tan of root 3 by 2c. This is a constant again. Take 2 common, that will get cancelled with this. So you have y plus x plus 1 upon 1 minus 2xy minus x minus y. You can call this as some constant a, remember. Call this as a constant a, remember. That's parameter or arbitrary constant. So what we'll get here? Y plus x plus 1 equals to, I have called this as a into 1 minus 2xy minus x minus y. Right? You can see that this is required differential, required solution. This is required solution. I did entire solution for you. Fine. This is just simplification. I hope you are clear with this. 8th question you can do very easily by you can see variable separable form. What we do, we keep sin x dx over here. I'll take cos down here. So sin x by cos x dx, and this cos y I'll take over here. So sin y upon cos y into dy equals to 0. Now it is in which form? You can see that it is in Vs form. So integrate it. Right. Now I think not a big task. Both are tan functions. You know, integral of tan, log of mod of sec x. So you can do it, remember. Question number 9. 9th question. There also, if you just observe, you can do by variable separable form very easily. 1 plus e raised to 2x into dy plus 1 plus y squared into e raised to x dx equals to 0. So we take 1 plus y square down here. So 1 upon 1 plus y square dy. E raised to x as it is, I'll take this one over here. So 1 plus e raised to 2x dx equals to 0. This is which form? VS form, variable separable form, remember. Now question is integration. First one is the standard formula, remember. You know integral of the first one. How will do the second one? Can you just recall? We had a number of such questions earlier. How will do the second one? I already told you, if you have any integration question, their exponential or log is involved. If nothing can be done, you put e raised to x equals to t substitution. So you will notice that this will be dt, just differentiate it. And e raised to x is t, remember. So this is 1 plus t squared. So you have this, and now both are very standard formula, remember. Tan inverse y, tan inverse t, and what about right hand side? There you have just constant. So you can put c there if you want. You can just put c here after the integration. I'm sure now you can do this. So I'll not be doing. This is a question of simple integration. ये नहीं हो रहा है तो इट मीन्स आपका इंटीग्रेशन प्रॉपर नहीं है. और in 9th क्वेश्चन में कुछ कंडीशन भी है, सो यू नीड टू गेट द सी, रिमेंबर. सो डू दैट. Question number 10, that's by observation you can see that x by y is involved. That means it's a homogeneous differential equation. Homogeneous differential equation, right? If you have x by y or y by x, it has to be homogeneous. But here you have x by y, so we need to get which expression? Not dy by dx, dx by dy, remember that corresponding form, right? We need to get the dx by dy. So this y into e raised to x by y go down, and here you x into e raised to x by y plus y square, this into this. Okay, now you know what's the next step. Put x by y equals to v substitution. So what is x? That is vy. Now we differentiate it with respect to y, remember. So dx by dy, v being constant as it is, sorry, not constant, v as it is, differentiation of y with respect to y1, y as it is, derivative of v with respect to y, derivative of v with respect to y, dv by dy. Call this as 1. We use this, so by 1, left hand side is placed by this much, remember. V plus y into dv by dy. Here we are going to place the value of x. What's the value of x? Vy into e raised to v plus y square as it is upon, what about y as it is, and this is e raised to v. You can see that y will get cancelled, and I'll take v on the other side, you know. dv by dy equals to 1y will get cancelled, so v into e raised to v, 1y as it is over here, e raised to v, this v I have taken on this side, so here minus v. Now just take the LCM, left hand side as it is, remember I'm just copying. V into e raised to v plus y minus v into e raised to v upon e raised to v. This will get cancelled. Even after cancelling this, you can see that this y will get cancelled with this y. So we are getting dv by dy equals to just 1 upon e raised to v. Now it's a so simple form, e raised to v into dv equals to dy. Finally we are reduced to this. You know that this is nothing but which linear equation? It is variable separable form now, remember. It is which form? Variable separable form. So now we integrate it. So let me integrate it. In homogeneous equation at the end it has to be variable separable form. So integral of e raised to v with respect to v equals to integral of 1 with respect to y. E raised to v, this is y plus c. Therefore e raised to v, what is v? You know, v was, just go back to beginning, x by y equals to y plus c. That's required solution. Okay, you know, but I just did it for you. It's not difficult for you, I'm sure. Okay. Question number 11. You are given this differential equation. I'll just open the bracket on the left hand side. So x into dx plus x into dy minus y into dx minus y into dy minus dx plus dy equals to 0. Now what I'll do, I'll take dx common from this and this. So what I'll get, x, then here minus y, here minus 1 into dx. And from this one and this one I'll take y common. So this is x, here minus y, and here you have plus 1 into dy equals to 0. Fine. Now you can see that this cannot be solved by variable separable form, because variables cannot be, separated here. This is not homogeneous also, because here 1 1 0, here 1 1 0, degrees are not same. Even this is not a linear differential equation also. So the only way to do this is put substitution. This is common in both. So what I'll do, I'll put x minus y equals to some new substitution. Let's put z, for example. And now you need dy by dx, so I'll differentiate it. So 1 minus dy by dx equals to dz by dx. Substitution, remember, because this is indirectly integration. Okay, so you need somewhere dy by dx here. So 1 minus dz by dx equals to dy by dx. Just interchanging these two. So we use this. And now from 1, you need to write dy by dx also first, remember. So from 1, dy by dx equals to, if I take 1 on the other side, minus sign will be there, remember. Dx is down here, so in the numerator you have this term. But this is z here, so z minus 1 into dx, that is this, upon this will be here in the denominator, so you have z plus 1. Just check place. This into dy, so z plus 1, and dx into this, so that this. And what is this? That you can write 1 minus dz by dx. So finally we have this 1 minus dz by dx equals to minus z minus 1 upon z plus 1. Okay, you can take this expression over here. So 1 plus z minus 1 upon z plus 1 equals to dz by dx. So if I take LCM here, 1 1 will get cancelled, so you have 2z upon z plus 1 equals to dz by dx. Now this can be solved by variable separable form very easily. So I'm using variable separable form. This I'll take over here, dx I'll write over here, remember. So you have 2 into dx. Here you have z plus 1 upon z into dz. Now this is purely in Vs form. You must have noticed this is because of that substitution. Now we integrate it. So integrating. Okay, integration will not be a difficult task because here this is just integral of 1, which is x. Z upon z1, integral of 1 is z. And what about this? Plus 1 upon z, that's log of mod of z, plus the constant of the integration, which is c. Now just go back, what was z? You know z was x minus y, plus log of x minus y plus c. And if I take both terms over here, this will be just 2x minus x plus y equals to log of mod of x minus y plus c. But this is a general solution. You are given certain condition in the question. What is that condition? When x is 0, y is minus 1. Use that condition. When x is 0, y is minus 1. Remember, that's given to you. So here this is minus 1, this is 0. So this is log 1, which is 0, and therefore you are getting c equals to minus 1. Therefore particular solution is finally, this is your final solution. Particular solution is x plus y, what is c? Minus 1, which I'll take over here, plus 1 equals to log of mod of x minus y. That's required particular solution. Question number 12, you are given this differential equation, e raised to minus 2 root x upon root x minus y upon root x into dx by dy equals to 1. So I'll take this one over there. So here you will get the dy by dx. This is e raised to minus 2 root x upon root x minus y upon root x. Now dy by dx, if I take this one over there, 1 upon root x into y, this one as it is this side, minus 2 root x upon root x. You understood what I did? I have just taken this expression over there. This is as it is this side. Now this is in which form? You must have noticed dy by dx plus p into y equals to q form. Here y, तो यहाँ पे भी y होना चाहिए. So what is your p? Your p will be this much, right? dy by dx का coefficient 1 होना चाहिए. And what's your q? Q is this right hand side expression. Fine. So now I think you can do it, I'm sure. Just this is a standard variable separable form. So you can do it. It's a good question. Okay. What about question number 13? It's very standard linear differential equation, remember. I'm just telling you it is linear differential equation. Just observe it. It is already in the standard form. What is p there? Cot x. What is q? That is right hand side expression. Okay. Question number 14. What about question number 14? You want the particular solution for this differential equation. X plus 1 into dy by dx equals to 2 times e raised to minus y minus 1. How will do this? This is a question. Is this homogeneous? Is this linear differential equation? Can we solve by variable separable form? Right? You are just given solve this differential equation. So you must choose the proper method, remember. Sometimes one question can be solved by two different methods also. You see by which method it can be solved very easily. That's what you have to do. Fine. Now here just I'll give you idea. You see this is purely about variable y and this is purely about variable x. So if you notice, it can be done by variable separable form. I'll take this down. 2 times e raised to minus y minus 1 into dy. And here 1 upon x plus 1 into dx. So this is which form now? This is nothing but VS form, variable separable form. This is variable separable form. Question is integration. How will integrate? That's the question. Right inside integral is too simple, remember. Here what I'll do, I'll write 1 upon and I'll take LCM, remember. So 2 minus e raised to y dy equals to 1 upon x plus 1. I hope now this is clear to you. What I did here, यहाँ पे मैंने क्या किया? I wrote 1 upon e raised to y. Then e raised to y will be multiplied with this and it becomes denominator of the denominator becomes numerator. Now you can think this is a standard form, this is a standard form. Integrate it and get the finally particular solution. अब होना चाहिए आपसे, remember. I did half of the solution. Question number 15 now. I'll do. The population of a village increases continuously at the rate proportional to the number of its inhabitants present at any time. Okay. So we need to take a variable here at any time t. Let x equals to number of inhabitants, right? If you remember, this is same as that bacteria question which we did earlier. Let x be number of inhabitants at any time t. So what is given in the question? Change in the variable x with respect to time is proportional to number of inhabitants, so that is x. So therefore dx by dt equals to kx, where k is, fixed constant of the proportionality. Now this is a differential equation. What is this? This is a differential equation. So we solve it. How will solve this? As we did earlier. We take x down here. So dx by x equals to k dt. We integrate this. What's the integration on the left hand side? Log x. Here we have kt plus we write usually in such question log c. Remember, this is by integration. This is by integration we are getting this, by integrating. Okay. Now we just simplify. I'll take log over here, so it will be minus. Minus will be, division equals to kt. So therefore, x by c equals to e raised to kt. If you drop log, you have exponential. If your log x equals to y to the base e, what is x? E raised to y, remember. So we have x equals to c times e raised to kt. This is main equation, solution of the given differential equation. Let me call this as 1 here. What are the unknowns there? C and k. C is arbitrary constant, k is that fixed constant. So we must have two conditions in the question. So we need to get the constant c as well as k, remember. Now what's the first condition? The population of village was 20,000 in 1999. So if t equals to 0, that is in 1999. This is standard way of doing such question in the beginning. What is number of inhabitants? 20,000. Right. So by 1, if I place these two values, x is 20,000, C as it is, e raised to 0. So you got C. What is C? 20,000. Fine, you have C. Now again we use 1 and we use the other condition. What is that other condition? If t equals to, now the population is which year? 2004, that is after 5 years. So if t is 5, that's 2004, remember. 99 and 2004. What's the population? X equals to 25,000. So if I use again 1, we have, what is left hand side? Left hand side is 25,000. I'm using 1, remember. What is C? C आपको पता है? Now you got that 20,000. E raised to t of 5 हो गया, remember. So 5k. This by 1. Putting t equals to 5. So we get here 25 by 20. That is just 5 by 4 equals to e raised to 5k. Right? We keep this one in a side, remember. Okay? Now we answer the given question. What's the question? What will be the population in the village in 2009? So if t equals to how much now? 2009. 2009 means t equals to 10, remember. Why? Because beginning was 99, remember. So this is 2009. T equals to 10. Then what is x? That's the question. So let's go to by 1. By 1, x equals to C. What is C? 20,000. E raised to t equals to 10. So you have 10k. Fine? 10k, remember. So 20,000 here. But you know e raised to 5k. So what I'll do, I'll write e raised to 5k, the whole raised to 2. You know power of the power gets multiplied. Why I have expressed in this form? Because I know e raised to 5k. C already used, which is 20,000. So 20,000 into this, this is 5 by 4 the whole square. Okay, because here let me write e raised to 5k is 5 by 4. And therefore you have 20,000 into 25 by 16. Just simplify this. If you simplify this, you will get the 31,250. This will be the population of that village in which year? 2009, which is t here, remember, 10. Let's see these last 2-3 MCQs. Now in 16 number, you are given one differential equation, y dx minus x dy, the whole upon y equals to 0. The y you can take over here. This is y dx minus x dy equals to 0. You can just rearrange by variable separable form. X down here, y down here, dy equals to 0. You can integrate it. What's the integral of this? This is nothing but log of x, your log of y. At both the places I have log, so I can write log c here. Property of the log function, x by y equals to log c. And therefore x by y equals to c. And therefore x equals to c into y. Right? That is required solution. Which method I have used? Just variable separable form, remember, and this is nothing but your option C. Here I've done integration, remember, integrating over here. Question number 17, it's just formula based question. You have that corresponding standard linear differential equation. So what is integrating factor there? E raised to integral of p1 with respect to here, remember, y. This is integrating factor. Just you need to recall the theory portion. Okay. Now what's the solution? You need to keep the standard in your mind. What's the standard differential equations? Integrating factor e raised to integral of p dx, but here y. Solution y into integrating factor equals to inside the integral q into integrating factor with respect to x plus c. Here you are going to interchange the variable. So x into e raised to integral of p1 with respect to y inside the integral q into e raised to integral of p1 with respect to y here dx, but with respect to y remember plus c. That's your solution. We did it. Just recall the theory portion. I think this is again the option C. That's your option C. X into integrating factor inside the integral q into integrating factor with respect to y remember. That's your option C. Question number 18, last MCQ. How will solve the differential equation? See, it's not homogeneous because everywhere degree you are not getting same. You cannot separate the variables also because here you have mixed variables, so it cannot be done by variable separable form. So the last option is now what? Linear differential equation. So what I'll do, I'll get that form. I'll divide by x dx. So divide by dx with this e raised to x. So y into e raised to x plus 2x upon e raised to x equals to 0. Just have a look. Do cross multiplication, will get the above step. So dy by dx plus this upon this is just y, and I'll take this expression over here, minus 2x upon e raised to x. Now you can compare with which form? You can see that it is in the form of dy by dx plus p into y equals to q. It is in, linear differential equation form. Okay, so what is your p here? P is 1. And what's q? This right hand side expression is q, remember. This is q. So integrating factor will be e raised to integral of 1, which is e raised to x. And the solution is given by, what's the solution here? Solution is y into integrating factor inside the integral q, that is minus 2x upon e raised to x into integrating factor e raised to x dx. So here e raised to x will get cancelled. Y into e raised to x minus 2, and you are just left with x squared only once you integrate it. So therefore y into e raised to x plus x squared equals to c, which is required solution. That is nothing but the option C. Fine. So that's all in all about differential equation. There are a number of good illustrations. Remember, you must solve all illustrations. There are how many? Roughly 27, 28 illustrations. So go for those illustrations. 25 is good illustration. 24 is also good one. Don't ignore the illustrations. 23, all are standard illustrations. Once you are clear with all exercises, illustrations can be done very easily. Go for that.